So first look at the question. There is a graph given here, the speed time graph, right? In question number 6, there is a speed time graph which is given, and the weight of the car is 1000 kg, right? Weight of the car is given 1000 kg. Okay, you can see there are three portions of the graph, right? O to A to B, and B to C, right? Okay, this portion, and this portion, right? So as you already studied about motion, the very first chapter, right? You already have the idea, like whenever the line is a straight line, right? Okay, so what kind of motion is that? When it is parallel to the time axis, what type of motion is that? Yes or no? Now in the first part, you have to find what is the distance traveled by the car in first 2 seconds, right? In first 2 seconds. So on the x-axis, you can see there is a time, right? Okay, in seconds. So 0 second, 1 second, 2 second, right? So in 2 seconds, how much distance it have traveled? On the y-axis, speed is given, right? On y-axis, speed is there. On x-axis, time is there. So how you will find distance traveled in first 2 seconds? Can you tell me that? How distance is related to time and speed? Tell me. How distance is related to time and speed? Yes, anybody tell? What is the relation between distance, speed, and time?
Speed into time is distance.
Speed into time is distance, right? But here, this is a slanting line, right? So we cannot simply multiply speed and time to find out the distance, right? So what do we need to do? From 0 to 2 seconds, you can see this is the graph, right? Can you see this line? Yes or no? Alicia, Sama. So if we find the area of this triangle, can you see there is a triangle AOD, right? So if we take a perpendicular line over here, right, from A to on the x-axis, right, that is the time axis. So you can see there is a triangle, right? So in this triangle AOD, right? So if we find the area of this triangle, what we will get? We will find the distance. Are you getting that? So area of speed time graph gives you distance. Are you getting that? Okay. So write down distance traveled. Distance traveled by the car in first 2 seconds. This is equal to area of triangle OAD, right? Area of triangle OAD. So area of triangle AOD. So what is the area of the triangle? What is the formula of finding the area of the triangle? Half into base into height, right? So half into B into H, right? So look at this triangle. So if we find the area of this triangle, right? So what is its base? Base is how many units? 0 to 2. 2 units. Base is 2 units. And what is the height? This is the height, right? And this is how much unit? From here to here. This is, tell me, 15. Getting that? So base is 2 and height is 15, right? So you can read on the x-axis and the y-axis for B and H, and you can put the same here. So half into base is 2 and height is 15. Getting that? 2 will cancel and this will become 15 meters. Is that clear? Right. So what is the distance traveled by the car in first 2 seconds? That is 15 meters. Now in the second part. In second part of the question, you have to find the braking force. What is the braking force applied at the end of 5 seconds to bring the car to stop within 1 second, right? So if you just study this graph, what is happening? Initially, its speed is increasing with time. After point A, right? A to B, from this to this point, speed is uniform, right? Means time is increasing, but speed is not increasing. Means the car is moving with uniform velocity or the uniform speed. Are you getting my point? Right? Now at point B, you can see that its speed is decreasing. It is going down, right? Okay. And at t is equal to 6 seconds, it stops. Or what is happening? At t is equal to 6 seconds, what is happening? Brake is applied, right? So you have to find that braking force which is applied at the end of 5 seconds. Means B point pe kitna braking force apply hua, right? So that it brings the car to stop within 1 second. 1 second mein hi, like 5 to 6 second mein hi, right? In this 1 second, it stops, right? Have you understood the question? Yes or no? So now we have to find this braking force which is applied at the end of this 5 seconds so that it stops in just 1 second, right? That means we have to find the force. Is that clear? Yes, I getting that? Okay. So how to do that? Okay. So write down braking force. Braking force means F you have to find. F is mass into acceleration.
Ma'am, I think
Yes or
it's
no?
15 meters square.
15 meter square. It is minus 15 meter square, right? Now what is the mass of the car? Mass of the car is 1000 kg. It is given in the question.
No, ma'am, in first part, 15 meters square area.
No, no, it is not meter. Yeah, yeah, of course. No, this is the distance traveled. Area of triangle doesn't mean that it will come in the square units. Okay. Here it will come in meters, right? So it is
Oh,
distance.
distance. Okay.
Okay. This is not meter square, this is meter only, right? If you're confused, let me tell you that this B is your time, right? Which is in seconds. So 2 seconds into 15. This H is your speed, meter per second square. Are you getting that? Sorry, meter per second, not per second square. So second will cut, and what you will get? Meter only. Understood? So this is how you will get the unit. Okay. Now, so M is 1000 kg, and what is the acceleration? What is the initial velocity at this point? You have already got it, right? And from the graph, at B point, what is the velocity? It is 15. Okay. So 15 से start हो रही है decrease होना, right? That means U is 15 meter per second. And what is the final velocity? Getting that? And what is the final velocity? V equal to 0 because it will stop. Are you getting that? Okay. So write down mass is this. Initial velocity is 15 meter per second. And final velocity is 0. Right? So first we will find the acceleration. Acceleration is V minus U upon T. Getting it? Okay. So 0 minus 15 upon T. In how much time its velocity changes from 15 meter per second to 0? It is in just 1 second. Getting it? So what is the acceleration? Minus 15 meter per second square, right? Now we can easily find the force, braking force. Force F is equal to M into A, right? The mass is 1000 kg into acceleration minus 15, right? So what this negative sign shows? That it is a retardation. This is not an acceleration. This is a negative acceleration. Means it is retardation, right? Velocity is decreasing. Okay, so it will become minus 15,000 Newton. So what is the braking force? Braking force is minus 15,000 Newton. This negative sign shows that the direction of the force is opposite to the direction of the motion. Is that clear? Yes or no? So in this way, we can find the distance traveled and the braking force. Is that clear? Yes. Tell me, is that clear or not? Question number 7. A constant force of friction of 50 Newton is acting on a body of mass 200 kg, moving initially with a speed of 15 meter per second. Okay. How long does the body take to stop, and what distance will it cover before coming to rest? Right. So, very first we will write down what is given. So, what is given in this question? If you can see here, this is the force of friction, right? Force of friction is 50 Newton. Mass of the body is 200 kg. M is given, right? And it is moving initially with a speed of 15 meter per second, means U is 15 meter per second, right? Are you getting that? Okay. So write down. F is 50 Newton.
Ma'am, in this question, which we did just now, that diagram, if it's given find the average velocity, then how will we do that?
For that, you need to find the total distance, then divide by total time.
Oh, so total distance, like it is changing it.
Yeah. So force is this, mass is this, and U is this, right? So as we know that acceleration is not given here, but force and mass is given. So we can find the acceleration, right? F is equal to M into A. A will be F upon M, right? F is 50 and M is 200, right? Always remember, before putting the values within the formula, they all should be in their SI unit, right? So mass SI unit is kg, that is correct. Force is in Newton, so that is correct. Okay, so we are directly writing this, right? So this will become 0.25 meter per second square. Since it is decreasing, right? Okay, force is the friction force. So we can take the negative sign here. Okay, now from the first equation of motion, we know that V is equals to U plus AT. Okay, or from here you can say that T is equals to V minus U upon A. Yes or no? Because we have to find the time here, right? So final initial velocity, we already know. Acceleration, we have already find it out, right? So what is the final velocity? Because it is coming to rest, it is stops after some time. So final velocity will be 0, right? So write down 0 minus initial velocity with which it was moving is 15 divided by minus 0.25. Okay, the negative acceleration. So this is minus 15 upon minus 0.25, that is 60. So time which is taken, right, by the body to stop is 60 seconds, right? So because of this friction force, the body will stop after 60 seconds. Is that clear? Okay, so this is the first part of the question. Now, in the second part of the question, what we have to find? What distance will it cover before coming to rest, right? Okay, so we have to find that how much distance it have covered when it is coming to, before coming to rest, right? For that, you need to find out the distance traveled by the body, right? And you can use the second equation of motion, right? That is S is equal to UT plus half AT square, right on, right? So now put the values. Now, what is the initial velocity? Okay, so as we know, second equation of motion, S is equal to UT plus half AT square, right? Initial velocity is 15 meter per second. Time we have already find it out in the previous part, 60 seconds minus, or you can say plus 1 by 2 into A. Acceleration is negative, that is 0.25 minus 0.25 meter per second square into time 60 square, right? Now solve this. So this is 900 and this will become, yes, calculate this. 60 into 60 is 3600, right? Into 0.5, which is minus 900. So 900 minus, this can be cut, minus 450, right? So this is 450 meters, right? So means before coming to rest, it have covered 450 meter of distance. So this is your second part. S is equal to 450 meters. Okay. So acceleration will be negative because it is retardation, right? It is decreasing, negative acceleration. So remember the sign, it is very, very important, right? Okay. Are you getting that? So in this way, we can find out the time and the distance. Now look at this question, question number 8. An iron sphere of mass 1 kg is dropped from a height of 10 meter. Mass of 1 kg is dropped at a height of 10 meter. If the acceleration of the sphere is 9.8 meter per second square, which is g, calculate the momentum transferred to the ground by the ball. Means you have to find the momentum of the ball when it hit the ground. Is that clear? So first write down what is given to you. So can you tell me what is the initial velocity? What is the initial velocity of this iron sphere?
0.
It is 0 because it is dropped. Okay. So there is no initial velocity, right? So u is 0. Okay. Now what is the distance traveled by this iron sphere before it touches the ground? From what height it is dropped? That is the distance traveled. Means S is 10 meters, right? Acceleration A, 9.8 meter per second square, right? Now what do you have to find? You have to find the momentum. Now what is momentum? Momentum is mass into velocity. Mass is also given. Mass of ball is given m 1 kg. So mass you already know. Now what do you need to find the momentum? V. You have to find velocity, final velocity when it hits the ground. Right? So you have to find final velocity to find out the momentum. Are you getting my point? Final velocity V you have to find. Okay. So the third equation of motion, if you know, by third equation of motion, we have V square is equal to U square plus 2AS. Getting it? So V square is equal to U square, U is 0, plus 2 into acceleration 9.8 into S. S is 10 meters. Right? So from here you can easily find the V. So 2 into 9.8 into 10 is what? 2 into 98 is what? 196. Right? So V square is equal to 196. So what is V? Square root of 196. So 196 is the square of which number? Can you tell me? 196 is the square of 14, right? So what is the final velocity? When it hits the ground, it is 14 meter per second. Now we have to find like momentum of the sphere, which is just before it touches the ground. That will be transferred to the ground, yes or no? Okay. So momentum, write down momentum of the sphere just before it touches the ground. is m into v, final velocity v, right? So find it out, 1 kg into final velocity 14 meter per second. So it will become 14 kg meter per second. So the momentum P, momentum is P. P is 14 kg meter per second. Means on reaching the ground, the iron sphere comes to rest. So its final momentum is equal to 0. Final momentum 0 हो जाएगा, right? Okay. So according to the law of conservation of momentum, momentum transferred to the ground is equal to the momentum of the sphere just before it comes to the rest. Okay, so that momentum will be transferred to the ground. Okay, so momentum before collision and momentum after collision is same. That I told you, like the conservation of momentum, right? So what momentum will be transferred to the ground? That will be equal to the momentum of the sphere, the spherical ball, just before it touches the ground. And that is 14 kg meter per second. Is that clear to you? Yes or no? Please tell. So noted now. So look at this question number 9. A bullet of 10 gram, the weight of the bullet is 10 gram, strikes a sandbag at a speed of 10 to the power 3 meter per second. This is the speed, initial velocity of the bullet, and gets embedded after traveling 5 centimeters, 5 centimeter in the within the bag, right? Now what you have to find? You have to find the resistive force exerted by the sand on the bullet and the time taken by the bullet to come to the rest. Okay, time you have to find, and the force, resistive force exerted by the sand on the bullet. You have to find F and T. Is that clear? So first write down what is given to you. Mass of the bullet is 10 gram. So write down it is 10 G. Okay, first convert this into kg, 0.01 kilogram, right? Okay, because G is not the SI unit. Initial velocity is given 10 to the power 3 meter per second. Okay. Final velocity, because it is coming to rest, final velocity will be 0. Distance traveled by the bullet before coming to rest is 5 centimeter. Again, centimeter is not the SI unit. You have to convert this into meter. So this will become 0.05 meters. Right? Now you have to find T and F. To find F, you need to find acceleration also. Right? Now, the first part. Resistive force exerted by the sand on the bullet. Okay, what we have? S, U, V. This much we have. So we can use the third equation of motion. Yes or no? So using third equation of motion, we can find the acceleration. What is that? V square is equal to U square plus 2AS. Right? Okay. Or you can write down. So just write down each and everything. So V is 0. Final velocity. Initial velocity is 10 to the power 3 square. Getting it? Plus 2 into A into S. S is what? 5 centimeter. That is 0.05 meters. Right? Okay. So find this. So A will become 0 minus 10 to the power 3 whole square upon 2 into 0.05. Getting that? So this is 10 to the power 6 minus, getting it? 2 into 0.05 will become 0.1, right? So acceleration will be minus 10 to the power 6. Now 0.1 means 10 here, 10 to the power 1. So that is minus 10 to the power 7, right? So acceleration is minus 10 to the power 7 meter per second square. So this negative sign automatically came, negative sign here, which shows this acceleration is a negative acceleration, means it is retardation, right? And it is coming to rest after some time. Now, we have to find the force applied by the the resistive force applied by the bag on the bullet, right? So we can find out F is equal to M into A, right? M is the mass of the bullet, which is 0.01 kg, into acceleration, which is minus 10 to the power 7 meter per second square. So this is equal to 0.01 means 1 upon 100 into minus 10 to the power 7. So it will become minus 10 to the power 5 meter. Okay. So what will be the force? It is minus 10 to the power 5 Newton. Okay.
Ma'am,
So this
what it
negative, this is the resistive force exerted by the sand on the bullet, right? And this negative sign shows that the force is against the direction of the motion. Now, to find time, the second part of the question. Time taken by bullet. Time taken by bullet to come to rest. Okay. Means rest पोजीशन में आने से पहले, वेलोसिटी 0 होने से पहले, राइट, स्टॉप होने से पहले उसने कितना डिस्टेंस कवर किया, राइट, सॉरी, कितने टाइम में वो रेस्ट पे आया, राइट. डिस्टेंस कवर्ड इज ऑलरेडी गिवन इन द क्वेश्चन, राइट, बट नाउ यू हैव टू फाइंड हाउ मच टाइम इट हैव टेकन टू कम टू रेस्ट, राइट. नाउ वी नो दैट अगेन द फर्स्ट इक्वेशन ऑफ मोशन v इज इक्वल टू u प्लस at. ठीक है. अब एक्सेलरेशन आपको पता है, u पता है, v पता है, t आप इजीली फाइंड आउट कर सकते हो. Are you getting my point? Right? So acceleration will be v minus u upon t. Right? Final velocity 0 है. Initial velocity 10 to the power 3 है. It is already given in the question. And acceleration, oh sorry, time. This is a and this is t and this is a. Yeah. And acceleration we have already found it out here. That is 10 to the power minus 10 to the power 7 meter per second square. So write it here. Right? Okay. So this negative sign show will cut, right? And this will become 10 to the power 3 minus 7. That is 10 to the power minus 4 seconds. So in how much time it come to rest? In very, very short span of time, right? Okay, 10 to the power minus 4 seconds. So this shows that it comes to rest in very, very small time. Right? Or you can say t is equal to 1 upon 10 to the power 4 seconds. Is that clear? Right? Remember, time can never be negative. So if you are getting the value for time which is negative, that means you have done something wrong. Okay. So these are something which, by this you can check whether you are doing correctly or not. Similarly, distance. Distance can never be negative. If you're getting negative distance, that means you have done something wrong. You have put some value with wrong sign. Are you getting my point? Acceleration can be negative. Force can be negative. Time, distance can never be negative. Is that clear? Are you getting that? Yes or no? So is this clear? Like how to find the time taken by the bullet before it is coming to rest? Now tell me if you have any doubt related to this question.